Pre-calculus, we're going to cover lesson 2.3 part B in this video. It corresponds to lesson 2.7 in your textbook. We're going to be solving quadratic and polynomial inequalities, and there is basically a 5-step process over here in the margin that you're going to need to follow. The first step says to set your polynomial equal or less, in this case on number 1, less than 0. You want to keep your polynomial on the left side. So on number 1, I need you to subtract the 16 over first. It is incorrect to take this problem and simply take the square root of both sides. You can't do that. That is incorrect. So what you always want to do is you want to start by moving the problem to the left side and keeping the 0 on the right side. The second step, it says to factor or use the quadratic formula to get key numbers. So I'm going to factor this. And your key numbers are obtained by setting these factors equal to 0. So if I set this factor equal to 0, I'll get 4. And if I set this one equal to 0, I'll get -4. Then step 3 says to test or set up a number line with test regions. Let me put that in a different place. So I'm going to put -4 and 4 on a number line. Now you want to make sure you put those key numbers in numerical order on your number line. What you're going to do next is you're going to choose an x value on the left side of -4.
107 is here, and that is the last bus for this evening. Bus 107.
So I've chosen an x value on the left side of -4, an x value in between -4 and 4, and an x value bigger than 4. From here, what I'm going to do is I'm going to take my -5, and I'm going to put it right here and right here. I'm going to put it in for x. And I'm just going to talk about the sign of the result. So when I put in -5 first, I get -9. That's a negative number. Then when I put -5 in right here, that gives me a -1, which is still negative. Then I say a negative times a negative, is that less than or equal to 0? A negative times a negative is positive. It's not less than or equal to 0. So I'm going to say this region is false. In other words, there's no x value in that part of my number line where I can take and plug it back in right here for x and come out with a true statement. Now I'm going to put in 0. So I'm going to put 0 in for x where the yellow x's are. So I'm going to have 0 minus 4 is negative. 0 plus 4 is positive. That product is negative, and I'm looking for less than 0, so that region's true. And then I'm going to do the same thing on the last bit here. So I'm going to put 5 in. That's positive. 5 plus 4 is positive. A positive times a positive is positive. It's not less than 0, so I'm going to say false. So my answer then is where it's true, and because this is equal to, I'm going to have brackets. And so my solution is -4 to 4. That means if I choose any number in that region, or including the endpoints, and plug it back into the original problem, I'll have a true inequality. Okay, number 2, we're going to do the same thing. Get my 2 out of the way. Okay, we're going to make sure the problem's on the left, and it is, so then we're going to factor it. This produces a 2, this produces a 3. These are our critical numbers or key numbers. 2, 3, pick a number in each region. So you can use fractions or decimals if you have to. And then I'm going to plug them in. Is 1 minus 2 positive or negative? It's negative. And remember, you're plugging the numbers, the test values in right here in the blue X's. So 1 goes in, 1 minus 2 is negative, 1 minus 3 is negative. A negative times a negative is a positive, but over here, I'm looking for a product that is negative. So again, this one is false. When I put in 2.5, I get a positive times a negative, and that product is negative, which is what I want. And when I put in 3, I get a positive when I put in 4, I get a positive and a positive, and that is a positive product, which is not what I want, so false. And then again, I shade where it's true, and this one is going to use parentheses. So 2, 3. So all of those decimal values in between 2 and 3 would work when I plug them in for x and calculate. I'm going to get something less than 0. Okay. Let's try one that has greater than. So number 3, I'm going to go ahead and factor that. But first I'm going to get it set to 0. All right, so if I factor that, factors of, let's see, 4 that add to negative 4 are negative 2 and negative 2. So I'm going to divide by 4. I'm just doing the bottoms up process. So that's 1/2, so that's 2x minus 1, 2x minus 1. And so that's 2x minus 1 squared. And so 1/2 goes on my number line. So in this case, I only have one key number. All right, if I test something like x equals 0 or x equals 1, if I put 0 in, I'll have a negative number, but I'm squaring it. Squaring it gives me something positive, so this region's going to be true. If I put 1 in, and again I'm putting 1 in right here, I would get 2 times 1 minus 1, which is positive 1. Square it, I still have a positive number. Oops. And so this is true on both sides. But because it's just greater than and not equal to, I'm going to have to put parentheses on both sides. In other words, I'm going to avoid 1/2. And the reason why we're avoiding 1/2 is because if you take 1/2 and you actually plug it in for x right here, you're going to get 0, and 0 is not greater than itself. And then we ended class with number 4. So most classes finished it. So we got it set to 0. We're going to factor it. We're going to set up our intervals. Okay, remember you're always setting your factors equal to 0 to get those key numbers. And then we're going to see where it's true and where it's false. So I'm going to say x is negative 4. I'm going to just go with 0, and I'm going to go with 9. Negative 4 is going to give me negative 4 minus 8, so a negative. Negative 4 plus 3 is a negative. A negative times a negative is a positive, and that is what I want. So true. 0 will give me a negative 8 times a 3. Oops. Let's put a positive in there. And a negative times a positive is a negative. And so I'm going to say false here because I want positive. And then I'm going to do 9. So 9 minus 8 is positive. 9 plus 3 is positive. So I have a positive, and so that's true. Again, you're shading where it's true. And I'm using brackets because of the equal to. Oops, I missed that one, didn't I? Let's fix that. Okay. So here we go. Negative infinity to negative 3, union 8 to infinity. And that's it. Hope that helps.